The aim of this video is to look at solving cubics using two main methods, the factor theorem and technology. And the technology is to check, or unless you're specifically told to use it, the main thing I want to show is the factor theorem. And one of the factors is a linear factor. It's a type of cubic. And the cubic we've got here is 6x cubed plus 17x squared minus 4x minus 3. Well, maybe we'll do the easy bit first, the technology. On a TI Inspire, we basically hit the menu. You can just be in calculator and just hit the menu, algebra and polynomial tools. And basically we're going to find the roots of a polynomial, and we're looking at a cubic, so it's degree 3. The roots are real. We're not looking at complex roots. Okay, that's outside the scope of what we're doing in this math methods video. So enter that in, and remember it was 6x cubed, so see how it's got all of the coefficients there. Pause the video to have a closer look if you can't see what's going on. But we had 6x cubed, 17x squared minus 4x minus 3 was equal to 0. We put in, and that's the statement, hit enter. So that's what we should get: -3, -1/3, and a half. The other way of using technology to do this is graphically. Okay, so that's the algebraic way of using technology. And remember those answers: -3, -1/3, and a half. And the other way is to plot the function, okay, and then hit menu, analyze graph, and we're looking for the zeros because the zeros are the solutions, right? Remember that? So lower boundary, upper boundary, -3 is one of the answers. Do it again. Analyze graph. 0 either side, and look, decimal approximation of a -1/3, and one more time. Analyze graph. 0, and look, we got a half. So that matches -3, -1/3 and a half. -3, -1/3 and a half. Now, the analytical method, factor theorem. Okay, from last time, basically using the factor theorem, we need to look at factors of -3. So we've got plus or minus 1 and plus or minus 3. Okay, so you try each of them. So you try P of 1, P of -1, P of 3, and P of -3. And in fact, just to keep things short video wise, P of -3 is the one that works, because we want, when P of x equals 0, we have basically x minus alpha. So, well, I should say when P of alpha equals 0, so I don't get things confused, x minus alpha is a factor. That's from our previous work. Okay, so let's see what alpha has to be. Remember, it is minus, so I said that P of -3 works. I'll just show you why, because we've got sub these in to this is P of x, by the way, the given expression and the given equation, and we've got basically to sub the value in for alpha, which is -3, so 6 times -3 cubed plus 17 by -3 squared minus 4 by -3 minus 3. We crunch all that, we get what, -162 plus 153. That's a 153. 153 plus 12 minus 3, and that comes out as 0. So that is a factor. So x minus alpha, if alpha is -3, okay, so x minus -3 is a factor, or x plus 3, in other words, is a factor. So now we use polynomial division, and here we go. So since x plus 3 is a factor, we will have to get our remainder equal to 0. Okay, something has gone wrong if that doesn't happen, and you might have to go back and just double check that that is a factor and try something else. If it's not, you might have made a mistake. So the remainder is 0, and let's see, so we've got 6x cubed by timesing that by 6x squared, and that's 18x squared. Subtract, we have negative 1x squared, bring down the 4x, and we've got negative x squared if we times it by negative x, and we got minus 3x there. Eliminates the squared terms. See if I can scroll down, and basically that's 4 plus 3 essentially. Negative 4 plus 3 is negative 1x. Okay, and bring down the minus 3, and we've got x minus 3 there if we times by negative 1, and so that does leave a remainder of 0. So that's all gone well, so we don't have to go back and find another alpha so that we can find x minus alpha. Okay, we found it correctly, and that checks that out. So at the moment we've got x plus 3, 6x squared minus x minus 1. Now we need to see if that'll factorize. One way of doing it is looking at the determinant, which is b squared minus 4ac, and b squared minus 4ac is negative 1 squared minus 4 times 6 times negative 1, which is 1. Now all of this here, that's negative 24, so 1 minus negative 24 is 1 plus 24, which is 25, so it can be factorized, and basically we need to factorize this here. So we've got two numbers that times together to be negative 6 and add together to be negative 1. Okay, so that will decompose the middle term, negative 3x plus 2x minus 1, and we've got 3x, 2x minus 1 plus 1 outside of 2x minus 1, 1 outside of 2x minus 1, sorry, there we go, that's what I get for rushing. Let's try that bit again, fix it up. 2x minus 1, and we've got 3x plus 1, 2x minus 1. That's the quadratic part. So overall, let's move down a bit further. We have factors x plus 3, therefore x plus 3, 3x plus 1, 2x minus 1 equals 0. Null factor law time, so x equals negative 3, looking at this first factor, or 3x plus 1 equals 0 for the second factor, for the null factor law, and that means that 3x equals negative 1, x equals negative 1/3, which was one of our factors we saw when we were doing this with technology. Okay, time for the final factor. We've got 2x minus 1 equals 0, and that means 2x equals 1, and we've got x equals a half. So there are our solutions. X equals negative 3, or x equals negative 1/3, or x equals 1/2, which we found before using technology.